Good afternoon. We're about to start, so get ready for some great pitches for this Buildings Challenge, Big Innovation Pitch Buildings Challenge. My name's Gilly Hobbs. I'm our director in the Strategy and Innovation team at BRE. So I'm one of the judges along with...
Hi everyone, my name's Asan Khan. I'm Director of Research and Innovation at the Active Building Centre. Quite interesting to hear about the pitches we've got today, so we've had a bit of a snoop around and really interesting to hear how we develop these going forward.
Hi, I'm Peter Cablehorn from the Construction Products Association, and my background is as an architect, so I come at this from a design, from a construction and from a products point of view, and I've had a snoop around as well.
Great, right, so each of the shortlisted entrants have basically got a 5-minute pitch and then a 5-minute grilling by the judges. So we'll try to be, well, I don't know if he's going to be that gentle, but you know, we won't be too nasty, hopefully.
Sorry.
So at the end of that, so there'll be, I think there's 6. So at the end of that whole session, we'll go off and make a decision, hopefully. And what I would then suggest is that all the companies that are pitching maybe come up here, and there'll be a Q&A with the audience whilst we're going off with our deliberations. So hopefully everybody knows what's going to happen in the next hour and a bit now. But there could be some surprises, you never know. So to start off with, I think it's Cheese is going to be starting proceedings. So 5 minutes starts from when you set off your first slide. Thank you very much.
Right, glasses. Right. Hello. The Cheese Project is a not-for-profit company dedicated to reducing domestic building energy. And usually we combine technical expertise with community engagement. We exist because the world is heating up, and you can see the Earth now has a 1-degree temperature rise. To avoid 4 degrees rise, energy reduction is needed now. UK energy between transport, industry, domestic, it's roughly about a third domestic, or as in buildings and so on. They are difficult to retrofit and so on. Housing ownership, private, rented and owner-occupied is 80% and very difficult to reduce. Residents have no clue what an EPC does. It gives a little bit of help, millions of houses to tackle, but how to do it. Now, a few years ago, whilst pondering this situation, I realised my 40 years career in thermal imaging showed that it found faults and stimulated immediate action to fix them. So why not use it to inspect our houses? And the problem is that very few houses are surveyed because of the cost of it, few building thermographers, and we've got to get inside houses in order to do any surveying. The solution was get the kit cheap, do the survey incredibly quick, 2 hours, look at all services, and don't bother writing a report. And the idea was, would this work? So we put it into action. We trialled it at Yelm and Malvern, and it was a very comprehensive trial of technology and protocol over 3 winters. And we ended up doing 150 houses in the 3rd years. The feedback from that was very, very good. 65% had already acted within 3 months, mostly with draft proofing. So we formed a company called Energy Trace CIC to spread the concept to other parts of the UK. And we met this bunch called the Cheese Project Team in Bristol, the 3 guys there. And then they were inspired by this map of Bristol showing the areas where people haven't got enough money to heat and eat at the same time. Fortunately, a very low-cost miniature thermal camera iPhone appeared, plug-in. It was just available, so it solved the expensive kit problem. And then Jeremy Birch, one of those guys, wrote software and developed it so as we could do street surveying, which is then used in public engagement, like here at the Redlands Fair in Bristol. We put all the kit together into a nice box, and then myself and Jeremy who's a top-flight IT guy, developed our own application to run on the iPhone called HeatView. I introduced a blower door I had developed. This cost £150, very cheap. Draws in the drafts so you can see them with the thermal camera. And then I also wrote a CPD accredited course, 3-day training program, which Jeremy covers the IT in. You can see the interpretation of images being trained there. And now over 30 energy tracers have been trained and certified. 300 properties have been energy traced in Bristol, but together with all the other ones, we're approaching 1,000 houses now. It's used like this. The householder sees the picture on the tablet, sees the fault, and it compels them into action. And here you see a disaster of a extension, thank you, stripped floorboards, various window problems with it, missing insulation in walls. The big problem with dot and dab, which is a huge scandal. And then here, more dot and dab. We leave a report on a stick with it. We leave an energy pack so people can actually leave there, do their behaviour change. And then here's feedback analysed by University of West England, which repeats and gets the same results as got in Malvern. Masses of testimonials all over the place. Nobody hates us, they won't let us leave. We are expanding it now into segments, South East London Community Energy, Phoenix Housing Association, Bath just picked it up, we've got about 8 more in the loo. Future technology coming, a new camera, all our own design, hardware and so on. Thermoman, the whole system on an electric bike, so you can get around city centres. And now a project called Cheese Plus Plus Wise, warm up, and whatever it is. Financially, we have got a balanced situation. We need funding to expand it from hundreds of houses per year to thousands. That's the main reason for that. And finally, we've won a nice award from Community Energy as the most inspiring energy management and conservation project in England and Wales. Thank you for looking and listening, and that's the kit.
Hello, it's not going off. Just got some questions for you. You've got to have the grilling now, I'm afraid. Thank you for the presentation, really interesting. Could you just sort of explain a bit how it goes from doing the thermal imaging to knowing what you should be doing in terms of retrofitting your house?
Right.
What are the sort of steps in between the thermal imaging and, the
I
what's
view
going to
that
work?
the thermal imaging. Can you all hear? Yeah. I view it that the thermal imaging gets you ground truth is what's happening in the building. It's not a computer model like EPC and so on. You see the temperature differences. We look very closely at the surface temperature and comparing it to the ambient temperature, which gives us an idea of the heat inflow into the surface and hence the U value as well. So it gives you that ground truth data, which then encourages the person to go down the DIY route, and it should then lead on into the formal retrofitting, which is what this exhibition is all about. And what we want to do is use the thermal imaging results to get into the EPC data, so as the EPC is made more accurate than what it is at the moment. That's to come.
Could you just tell us a little bit more about how accurate the camera is? I.e., if you've got a small area that's a problem, will it pick that up okay?
That's set by the resolution of the imager. It's around about 150, 160 pixels along a line. And with that, we would need to make 2 to 3 pixels area would be the minimum size to get a highly accurate figure. What we have found is that using this low, cheap resolution camera, you can overcome all that by simply going closer to it. So that's why we have it on a selfie stick. So we can pull it out and you can get up to do the tops of sash windows, all that sort of thing, and do the little tiny cracks and pick those up as well.
That's very good. Can I just do one more? previous generations of camera have had a problem in terms of trying to do this stuff in the summer when temperatures are just higher. Have I stolen your question? Right, sorry. So does this work at all times of the year?
Currently, we are surveying from November through to Easter, beginning of April, because we can easily get 10-degree temperature difference between the building inside and outside for good periods, so we get into thermal equilibrium. But in fact, I've done experimental work starting 2 years ago of doing surveys during the summer period. And this summer, we're actually going to be doing probably towards a dozen as a trial. This is back in Malvern. I know technically it's all on, and that would then expand the role to be an all-year-round job, and it would now mean the energy tracer can become a profession. And also, it opens up the door to thermally surveying new built houses before they are signed off, which would be very good because the new regulations are going to be every house airtight tested. Well, if you're going to airtight test it, do the damn thermal imaging at the same time. The extra cost is so low. But that will be a subject of a memorandum that we will write up for the autumn.
So just picking up on some of that, the details, the images you're capturing, you're essentially trying to get lay people, if I use that in a...
It's hard to hear you.
Sorry, is that better?
Yeah, that's better.
Yeah, you're trying to get people who are not thermal imaging experts to use thermal imaging and self-diagnose and then come up with a solution to that diagnostic problem. How do you get around problems like emissivity? How do you train people to see the indicators of those sorts of parameters?
It's very easy with emissivity because virtually everything is around about 0.9 in the real world. All we say to them is just don't look at anything metallic that's shiny. And we also tell them that what you're reading off a window pane is you're getting a degree of reflection of the surroundings. So look at it sideways on so you don't get a weak picture of yourself. And that gives them enough clue about what's going on in temperature difference. We don't hang a great deal on absolute temperature measurement. What we do is we're looking for temperature differences, comparing this with that. Compare the ceiling with the floor. That tells you what stratification is going on.
Okay, sorry, time's up. We'll have to carry on afterwards. Okay.
To get one more.
Yeah. Well, otherwise everybody else will have to have extra time as well. But thank you very much.
We all should.
So next up, we've got. No, I'd come back. So at the end of it, there'll be like a panel session essentially.
Hello, my name's Gary Giles and we are Oval. Plastic waste, one of the scourges of humanity, I think you'll agree. Well, we've got a way of sort of turning this into something really special. Using these four components. We can build walls, and we can build anything out of it. We can build interior walls and partitions. We can build humanitarian shelters. We can build flood defences out of it. And we can even build buildings like this. What we do is, we have long extruded pieces that we build in an offset manner, offsetting the front to the back, and build block shapes that aren't really block shapes. As you can see in the top right-hand corner, this is how fast it takes me to build this building. So I have built that structure in just under 15 minutes. We can run cables and pipes through conduits between courses. We can fit any sort of sockets and boxes and tie them straight flush to the wall. We can even sort of tie the oval wall to non-standard walls, or non-oval walls, should we say. We can attach windows and doors, and we can even put foundations in. As a final little piece, we can also build roof trusses. And we can paint it, clad it, or even wrap it. And when it's all said and done, we can wrap everything away pack everything away to 1/5 of its original size. We use no tools or glues. Only limited building skills are required. It's fully modular. And it's fire retardant. It's patented in the UK, Europe, USA, China. And basically, you can't reinvent the wheel, but we believe you can reinvent the wall. I'm Gary Giles. Any questions?
Thank you.
1, 2.
That was very fast. Well done. Thank you.
Well, that's the idea, sort of.
Yeah,
I try and mirror the
as
wall.
assembling it, maybe. Okay, so I mean, I've just been over in the resourceful materials actually doing the session there. So I'm quite interested in the whole plastic waste aspect of it.
Yes.
So could you just maybe expand upon what's going into it and where you're getting the stuff from?
Yeah, it's styrene based with an additive, with an iron oxide additive to make it sort of unflammable, should we say? Sources of material is quite wide, really. Sort of it's anything from plastic hangers to the stuff that your fridge comes pre-packed in, to parts from the interiors of scrap cars. So the source of material is quite extensive, to be honest. The nature of styrene, certainly expanded polystyrene, is such that it is very, very difficult to recycle because it's such a light stuff. It's hard to compact. It's hard to turn back into a closed cell, high impact polystyrene, which is what we do. And also the products that tend to be made from it tend to be quite low value products, things like CD cases, flower pots, that sort of thing. So what we're actually doing is making more of a high value, high usage product.
Gary, hi. I just want to focus a little bit on the actual performance. So
Yeah.
what sort of, first off, before we do that though, what sort of buildings are you proposing this would be used for?
We'll start off with things like garden ponds, humanitarian shelters. With the sort of, we haven't tested the full fire retardancy yet, but we sort of believe it's okay for exhibition type walls, that sort of thing, interior walls, because we also coat it with finally with an intumescent coating as well. Okay.
So what I'm really interested in
Yeah.
is its
Thermal efficiency.
its structural performance,
Yeah.
its thermal performance, acoustic performance,
Yeah.
and ability to be durable. In other words, taking it up, putting it down again.
Yeah.
Because I think it's a neat system, I've got to say.
Yeah.
But I'm slightly worried about maybe when you push it a bit outside, you push it in terms of performance, how well it can respond.
Right. Okay. So, as with all walls become stronger with corners. Okay. Once you put it in a corner tied to a wall, it becomes structurally very, very, very sound. At the minute, it's only 1/10 the weight of the equivalent in brick. So yes, technically speaking, if you just build a wall there, you can push it over, unless you sort of tie it to the floor, which you can, or you tie it to a wall, which you can using the pieces.
Right.
Thermal efficiency. The tests that we've done so far, bear in mind it's styrene, air gap styrene.
Yeah.
It's performing. This is work that's been done for us by Coventry University at the minute. About 1.8 to 2 times the equivalent of bricks with a thin insulating factor in the middle of it, you know. But once again, that is not official. That U factor is not official. That is just initial testing. Mm-hmm. Structural weight, empty. It looks like it's taken about a ton to a ton and a half before it bores. But we use the SED piece that you saw on there, pushes through the wall. So if you have a certain point where it's liable to crush, you can put the SED through to give it additional strength in that area where it needs it.
Okay. And acoustics?
Don't know yet.
I'm going to cut that off. So, Gary, how do you get to market?
How do we get to market?
Yeah, how do you get to market? What's your target market? And
Okay.
when are you going to get to scale?
Okay, we start with markets such as garden rooms, humanitarian shelters. That's our initial. Our initial product that we go to market with, bear in mind we can use the decals on it. It's going to sound a bit weird, but it's more for exposure. Dog kennels. A fully personalised dog kennel. Because it costs us nothing at all. It doesn't matter if we build a dog kennel or a full house. The principle is exactly the same.
Thank you.
Thank you very much. Do you have any more questions? I don't know where our
I do
timekeeper
actually.
seems to have gone.
Right, so you've just said dog kennels or sheds.
Yeah.
Essentially,
No,
you're
of course, we prefer outdoor living, shall we say?
outdoor living. So you're taking a waste material stream, you're displacing a timber-based product that essentially would last a similar
Yeah.
lifetime. Have you started looking at your cradle-to-grave methodology and life cycle? Are you doing any life cycle work to see
Yeah,
how you displace products?
Because we're not using glues, the argument is that, you know, the walls are very permanent things. Walls that you can reuse become very, very permanent things. That plastic of that nature in sea, if you took that and plunked a piece of that in the sea, it's going to take about 500 years to break down in salt water. So it's fairly permanent, but because we don't use glues, because we aren't using renders in its initial format, it becomes extremely reusable. If you decide you don't want the building there anymore, take it down and build 15 dog kennels.
Thank you.
Yeah.
Thank you very much.
Thank you.
I'm Graham Brown, founder of Envelope Architects. 5 minutes is going to be a bit of a struggle for me, so I better go on with it. There's 9 billion people in the world, according to Parikana, global economists, and we're entering the world of the megacity, and I don't know how we're going to get everyone around. Good services, people, and how we're going to construct in this very compressed world. Currently, we've got this sort of 2 chevron process on the motorways. Up above there, 6 cars per 2 chevrons. I think with autonomous travel, we can get it down to about 138. So we've been thinking about this quite a bit. I think if we can get rid of all the heavy lift trucks trundling along during the day and put it on the night shift, that would be wonderful. So I'm into autonomous night driving with HGVs. And the displaced drivers can come into the construction industry because we have a skills shortage. So lots of good stuff going on with diversity. We need more of that. There's more training, retraining of servicemen. But I think getting all the drivers off the road and into construction would be great. We need to make it more sexy, construction. So I think let's get people becoming, rather than labourers, technologists. So there's autonomous dumper trucks, there's remote control, amazing things on site. So we are really excited about that. So for the challenge, we have from scratch designed a variety of products that can work on site. So this is a catch-all, which is a pallet shifter for bricks. It can move sheets of plywood, plasterboard around there. It can put up plasterboard with self-balancing devices. It can go up ramps and stairs. It can even fly in insulated concrete formwork. So that's helping everyone on site. We've designed a 9-seater minibus that can be compartmented into 3 different sections with lots of complicated roller shutters and also expandable trailers, which we call satchel. So the whole door's a van. It comes a pickup truck after becoming a taxi, so very useful indeed. And then you can see door-to-door, 3-metre opening with no engine bay. We can move 5-metre I-beams around and 8 pallets, and also we can deliver it with this sort of pallet lifter roof rack and all the complexity of the roller shutters dividing spaces. Going up a scale, we've designed Shovel, which is a replacement for the HGV. HGVs do 8 miles per gallon. That's an awful lot of crud in our environment. So let's lift up the containers 150 mils to get over speed bumps and have these very fast, all directional, all steering, electric autonomous vehicles that can move goods around, including, luckily, some of our buildings. So the top right-hand corner is a converted sea container that is a micro flat, could be a hotel room, could be an office, could be retail units. And also because it's quite low, there's no trailer, we can get a container and a half under the bridges. So very, very efficient. It can go on the train, it can go on the road, it's kind of fully versatile. It can even go on the Hyperloop. This is us messing about with Elon Musk's idea of the Hyperloop. So we've kind of got converted sea containers that go underside of the tubes there. It could be an elevated railway. Slide it, float it, stack it, and then you've got plug-and-play apartments that could also rest in pontoons. So we can actually do this. They're going to put 1 million people in between Oxford and Cambridge. We made a submission for that. So instead of putting 60 miles of track down on the earth, we could elevate it and leave that 60-mile a linear park. That's what I think. There's quad rail there. On the right, not quite the Hyperloop because we've got a few bends and twists. And keeping with that mobile idea, because I'm very interested in mobile demographics, we're very interested in populating the tidal lagoons, which I think should happen in Swansea and Cardiff and the other 3 locations on the Devon coast. So we've designed a range of floating buildings that could then inhabit the 11 square metres of space. We also got mass production, mass personalisation with trying to blur the edges between office and work and home with our Bloom housing. This is the Sunday Times winner-up. So this is a very clever design with an elevated forest, which has underground a circular economy with plastics, actually, to convert plastics back into buildings, but also deal with flooding, which we're seeing a lot of. We want to revolutionise with these mobile containers workshops, so we call this Boxels, so we can liberate people to build their own houses with assisted robotic remote workers. And perhaps heavy lift airships as well. This is a future city that we've been playing with where heavy lift airships bring goods in and out. And perhaps they could also deliver perhaps a little bit of extreme boutique off-grid holiday relaxation. And ignore the back footing. Are we all right? So any questions? I'll cheekily have this running in the background.
Oh, wow. So very comprehensive in terms of all the different things you're going to tackle. But just in terms of what's your focus point, have you got a prototype? Are you focusing in on any one area to start off with?
No, I think I've been up to see a company in Swindon that does very large format 3D printing. So I think we're going to kind of move on and probably focus on the pallet mover. And also the pod at the end that we showed there. I think we're going to try and print that. If we win, perhaps we can show it here next year. So that's our focus. I think it's a lot of work to be done. We're going to need lots of friends. And we need to probably make some submissions to the various innovation grant organisations to move it on. So perhaps the next year is about model making and forging partnerships with the right people. We have submitted previously some innovation grants, and we've also the Orbital House that I showed you, the Sunday Times house. We want a place to build a show home up at Graven Hill. So good question though. We I guess effectively took the challenge in October and designed these modes of transport. So we're travelling at some pace.
Thank you. That was a wonderful journey. I don't quite understand why you would focus on the pallet or plasterboard installation device rather than I think what you called was the shovel, which was the transport node or end-to-end node. So what would you do first, and why do you do that first, and how do you get to market with that proposition?
Yeah, so there's constantly, so for example in Oslo, in about 2 weeks' time, there's an EV-AV conference, which I think is being dealt with one of the partners here. And you're right, it's quite a lot to focus on. So I guess a mobile device that I can manage is probably the pallet lifter that can fly, be self-balancing, and I think I'd probably like to work with a university. I have been on the Innovate Succeed programme, so I have started to forge relationships, but obviously I need to get collaborators involved, and I think if I'm successful here, that would give me the exposure that I'm looking for, and also the backing from the BRE. I've been to see them, they wanted the Orbital House put at Watford actually, so. But yeah, it's a big journey, it's quite a challenge, I realise. You know, people spend hundreds of millions of pounds on vehicles. But I have been working with this company that's 3D printed a car, so we'll see where that leads.
Thank you.
I'm kind of stumped.
Are you?
Because you've given us so much in terms of the scope, in terms of all the vision that you're trying to put forward. I suppose the challenge for me is that in order to get some of this delivered, I think you're going to have to focus on a few key themes, and in that way then start to deliver on the innovation and on the vision. So I would say my challenge to you is about the business plan
Yeah.
and how that is going to mature. Now, you said you have lots of friends, you have lots of contacts in terms of funding and stuff, but I think at the core of that, there needs to be some demonstrators and some proof to drive the funding, to drive the business plan. And have you got any thoughts on how you might do that?
Well, I know, so the pod, for example, we'll probably crowdfund that, which goes on a low loader, and we have got a piece of land where we can have it there and people can visit. So we'll probably do that, a crowdfunding that you can go and visit once it's built. I've got people like Lathan. I've got a whole suite of product makers that say, give me your shopping list and you can have it. It is quite an undertaking. You're right, I guess I've given you a massive vision, and you're right to say what you're going to focus on, but I thought it's important for this innovation show to say, what if we can fundamentally, massively change the way that goods are delivered to site and people, and I think that's important. So almost it goes from the small scale to the gigantic scale. It needs focus. You're absolutely right, I know that, and I am still collecting really good people, and I'm very much aware of the innovation grants that are coming up, so yes.
Great. Well, thank you very much.
Thank you.
Hello, good afternoon. My name is Shidong Zhao from University Hall. Today I'm going to introduce one of our recent innovation, which is a very low energy, low carbon heating system, employ innovative double source heat pump and multiple through flowing solar panel array. So SACE Center is a newly established research center at my supervision. We currently have 24 research, which is dedicated to research grant building, research project management, PhD supervision, as well as early career research training. This project is actually funded by BEIS and with a total funding value of around 2 million. Engaged with MPS, PCM, EPS, Hull City Council, with University Hall as a leader. And through 2 years of research, including simulation, optimization, prototyping, testing, and demo, we found our technology, compared to existing heat pump technology, can achieve around 20 to 40% of COP increasement, 35% more high seasonal performance factor, and 10% lower capital cost and 20% operational cost reduction. So, compared to existing air source heat pump and exhaust heat pump, our technology can maximize use of ventilation energy, minimize ventilation heat loss. We don't need additional electric input for default of heat pump, with a significant energy saving. And compared to conventional air source heat pump, exhaust heat pump, and conventional weapon injection heat pump technology, our technology need the lowest power input, and our capital cost remain lower than others, and operational cost is least, and we don't need additional heat supply. Our system can supply enough heat for the building without any external heat supply. This is a heat pump that can absorb exhaust air energy, as well as fresh air energy. It's a double source heat pump that lead to about 30 to 85% increase in heat pump COP. We also got multiple through solar panel array, which can average temperature of the solar panel, lead to significant increase in the solar efficiency, which is 8 to 15% high. We got 20% lower flow resistance and 10 to 25% higher energy efficiency. And we also make use of fast responsible heat storage heat change, which can catch up solar energy quickly delivered to the room space, only 20 minutes whenever solar radiation is available. A traditional system would need at least 3 hours, which is significant energy loss. We also make use of internet-based intelligent monitor control system that enable instant interaction between human and machine And actually, this is our third generation technology, which was protected by 2 UK patents. Our first generation technology actually have been very well applied. When 2017 was the site of Sustainable Technology Innovation Award, our second generation technology has won 2019 Newton Prize Finalist Award. This is our third generation technology. We hope to get something. And this technology has been applied to the Guangdong 5-star solar energy limited building, and also the applied science building University Hall, and shortly being Hall City Library. And we got first generation system, second generation system, and third generation system. And compared to current solar source heat pump, we got 37% energy saving, 30% low operation cost, and 20 to 40% increase in COP. We think technology got significant market potential. By 2030, I assume that's 100 million in the UK, and globally that will be 1 million. Thank you for your attention. Thank you very much.
Well, I'm not going to ask you too much about the energy technology side of things. I'll leave that to my fellow judges. I suppose what I'm quite interested in is the application. I mean, because the examples you showed were all sort of quite commercial, new build projects. Has it got applications in retrofit, either in the commercial or the domestic markets?
Actually, the project is technology is in demo stage. We got 3 buildings has been used this technology. We are currently prepared to transfer technology into business. We got a very good business partner, which is Idea Boiler, Group Athletic, EPS, and NPS. We try to set up joint venture in 2 or 3 months, and we have a very good commercial perspective. We got the Hull City Council, which is running zero carbon program, and University Hall got zero carbon campus. I think more than 15 cities in the UK running zero carbon neutral program. I think this is an opportunity for us. I think UK-wide, worldwide, that's a very good opportunity to make low carbon or near zero carbon. Actually, heating account for more than 30% of energy consumption in the UK. If we solve this problem, it's just a big step forward. We contribute to UK in terms of carbon neutral or environment protection and meet its commitment to carbon reduction.
Okay. Could we just focus a little bit on the solar collectors?
Mm-hmm.
So are they mainly contributing to? I'm just trying to work through it. They are thermal collectors,
Yes.
or right?
They're
So
going. Yeah, please. Yeah, okay.
no, I just wanted to be clear. So they're on a water circuit into the heat pump.
Yeah, actually, this is 2 technology in parallel.
Yeah.
Where in daytime, we make use of solar collector to deliver heat to the building. And in the night time, whenever solar radiation is not available, we run heat pump. This is a schedule. And our solar collector panel array is a totally different existing system. We make running of the working fluid from beginning to end, from end to beginning, make the multiple turning from beginning to end, that average temperature of the solar panel from beginning to end. With this temperature uniformly distributed, we can significantly increase the efficiency of the solar panel array. In the meantime, we use the fast responsible heat storage heat change that can store a lot of heat, could be used in the evening as well. So in that case, with our heat pump system, can only operate 3 or 4 hours a day. If we use solar panel, we can make a significant reduction in electric consumption for heat pump because reduce the operation time.
And does it imply that you would need underfloor heating as opposed to radiators?
We use radiator, but we recommend use outflow heating because the low temperature got high efficiency. But radiator is workable, but with little bit reduced efficiency.
So I agree with the coupling of technologies. So
Okay.
you have a solar thermal collector, a bank of phase change material, a heat pump, and a distribution system. By the time you've added all of those system components together in terms of cost, is it better not just to have a heat pump on its own? So what's your thoughts on that?
In terms of cost, we have a selection. We can have heat pump only, we can have a solar panel only, we can have both together. But if we have two technology together, we have around 3,400 pounds per 10 kilowatt unit. Because of significant energy saving and energy bill reduction, we should be able to recover our investment in about 2 years, 1.7 to 1.8 years, much shorter than air source, traditional air source heat pump, which is 5 to 6 years. So it's very energy efficient and quick money return.
Thank you. And one follow-up. So what is left that you've got to learn before your industrial partners can deliver this for you?
As a university, we are dedicated for research innovation. We solve the challenge or critical technology problem. And next step, we work with partners to look at the market, look at the operational strategy, business development, business planning, and we, as a university, would act as a technical supporting organization.
Thank you very much.
Thank you.
Thank you very much. My name is Agnes Sacco, and I'm a co-founder and managing director of AirX. We have developed a smart home solution to address the building retrofit market and addressing fuel poverty and climate change. My background is in building physics and passive house design, and prior to co-founding AirX, I led the delivery of 30,000 energy assessments in the most vulnerable, fuel-poor communities in London's social housing. And this was, in one hand, a very shocking but a very eye-opener experience to see what the real problems are in real people's home when it comes down to energy efficiency and damp condensation. So poorly insulated, drafty homes are contributing to 26% of the UK's greenhouse gas emissions. And recent research demonstrated that up to 15% of a home's total heat loss can be caused by air bricks, air ventilation holes. It's either at subfloor level or room level. So it's a seemingly small problem, but it has a massive impact. In the same time, if occupants are blocking these air vents permanently, it causes damp and condensation, risking their health. The NHS could save about £1 billion a year purely by treating asthma, and that's correlated to poor indoor air quality. So we have this dual problem of thermal efficiency and air exchange, which we are aiming to solve, and that's exactly what the AirX system does. It's basically an IoT-enabled smart ventilation control. It's technically an intelligent air brick that looks just like a normal regular air brick and replaces it like for like. The units have inbuilt sensors to monitor and analyze the environmental conditions like temperature, humidity, and air quality, which is layered with online weather data. The vents talk through radio frequency to a Wi-Fi connected home hub through which data can be viewed by the occupant and the landlord. And based on its cloud-based algorithms, it regulates the airflow to control the otherwise uncontrolled ventilation. So in one hand, reduces heat demand and reduces the energy bill for the residents, but also not compromising damp and air quality. And for the social landlord, it also provides real-time property diagnostics so that they could do preventative maintenance rather than expensive repair work. So the system is passive. We are not introducing any fan power, but utilizing the natural air movements like passive ventilation and stack effect. So as a result, it doesn't need to be connected to the mains power, but the units are running on long-lasting batteries. So it can be installed really quickly with next to no disruption to residents. It's a very simple masonry work. We typically partner up with cavity wall insulation installer, and it could be done with less than an hour per property. We have rolled out the product on hundreds of properties across the UK, from Portsmouth to the Midlands and the North. And we have done a series of independent academic validation, whereby we were monitoring in situ thermal performance, so U values of ground floor and air tightness. And we managed to prove about 10-15% of overall heat loss reduction, which means the payback can be as little as 2 to 3 years. And if we compare that with one of the closest proxy of traditional underfloor insulation, the AREX system can save half of the saving impact at 1/10 of the capital cost. So the payback could be 5 times better. And for an average typical social housing property, the total installed costs are about £500 per property. We have a market of about 50 million homes across Europe, and we're focusing on UK social housing first. And the immediate commercial opportunity here is eco. We are one of the first technology providers in the UK who received Ofgem approval under the energy company obligation to be adopted under this scheme, as part of which energy companies have to contribute hundreds of millions of pounds to reduce their carbon emission. So AREX is one of the lowest capital cost per carbon saved solutions. And we can see that loft and cavity wall insulation is always going to have a really good payback, but their market is nearly saturated. So we won lots of industry awards, and we were featured in national newspaper and local papers as well. And I think finally, to sum it up, we believe that we are bridging a very important gap within the building retrofit industry by being a smart connected home system, but without the complexity of the tech, because the installation is so simple and straightforward. Thank you very much.
Thank you for your presentation, the smart brick. So I suppose my question is I've got a couple actually, but I'll start with one. So I'm interested to see. So there's a battery within the brick itself. So I've got 2 questions, but they're linked. So how long does that battery last within the brick? But also, if it's going to be connected to the internet, how does it actually work? Is there then sort of a device in the home that is collecting that information? And have you experienced any sort of kickback in terms of privacy issues or concerns?
So typically there is about 5-6 air brick units per property. So they are the battery powered one, and currently the lifetime is about 3-4 years, but we're working on further optimization, and we are confident that about 6-7 years could be achieved fairly soon. And they are talking through radio frequency to a home hub that sits within the property. So it's plugged into the mains and plugged into the router, quite simply. We use Wi-Fi was the easiest option, and even in social housing, the Wi-Fi penetration is over 90%, but there is a fallback option of 2G and 3G that we use, and we used in the past. And importantly, even if there is any Wi-Fi intermittency, the actual vent units have their simplified algorithm, so it's still operational, but the only thing is that we don't see the data coming from that. And in terms of privacy and personal data, so as long as it's subfloor level, it's not so much of an issue. In terms of the room level products, there's a lot more security issues that we're getting our heads around it right now. So very valid points.
So can I just ask, where does the actual air brick get its power from?
So it's a long-lasting battery attached to it.
So
yeah.
Yes.
So
And so how long does that last?
3-4 years for now.
And what's the process of replacing it?
So for the actual installation, it does need a bit of a masonry work, but for the battery replacement, it doesn't, because the channel stays mortared in. So you remove the fascia, you slide it in, clip it on and off, and bring it back. So it could be a DIY as well.
So so you've got a cycle of battery replacement. You've got to do that. Okay. And the other one, I just wanted to. A lot of the examples you've shown us are venting into the masonry cavity, not entering into the house. That's what I mentioned, I think we met earlier.
Yep.
And so I find that a bit curious, actually. And you know, there are a limited amount of applications where the vent goes straight into the interior. So I think that's a challenge for you. More a comment than a question.
Most of the applications that we've done is mainly at the suspended ground, so subfloor level. And there is about 9 million properties, 8-9 million in the UK that covers that. And yes, within the room vent, are conscious of that some of them goes into the cavity, but also there is application that goes straight to the indoor area. So we are exploring that further.
So the judges have already picked up on two of my questions, so I'm going to throw them back at you. So I spent a lot of time with cybersecurity experts, which is terrifying. Have you done any penetration testing on your Raspberry Pi control system that you seem to have there? And my second question is, what happens when someone comes along and squirts a load of foam or polystyrene bead insulation into your cavity? So how do you solve those sort of problems?
So the wall cavity is either already insulated, in which case it's supposed to be sleeved. If it is not sleeved during the AirX install, we make sure that the installers are sleeving it, so protecting the beads to fall through. And even if there is the cavity wall insulation happens after, although in ideal scenario it happens in the same time because it's a lot more cost effective, but if it happens after, the channel protects that from it, so it shouldn't be an issue. What was the other question? Cybersecurity.
Cybersecurity, people in dark rooms hacking your device.
Yes. You mentioned the Raspberry Pi. So the earlier versions were based on Raspberry Pi. You picked it up, it's Pi Zero as well. But as consecutive versions, it's actually custom made, which will be rolled out on the market. But yeah.
Thank you. Don't talk to cybersecurity experts, they terrify everyone. So there we are.
Okay.
Thank you very much.
Thank you.
Good afternoon, my name is Daniel. I'm co-founder of Werner Homes. Thank you very much everybody for coming, and thank you very much to Future Build for the invitation to pitch here today. Our innovation is called DBUS. DBUS stands for Digital Building at Scale, which is exactly what we are trying to achieve here. Digitally building for the home building market in the UK. But what is the challenge we are facing? And it's actually this. And this is a typical UK site you will find all around the country. And this picture was taken by myself on a site. We go back with more than a decade of construction experience. You see waste all around, materials being broken, the cars far too close to the site, so health and safety issues, and the skilled worker having a nap. So this is what we are up against with. What is our vision? What is the vision of our innovation? Our innovation aims to have a positive social and environmental impact by modernizing the home building industry. What do I mean by social, actually? Social, we all know about the government target in 2025 to build 300,000 homes. We are about short of 100,000 today. Social, we have seen the skilled worker having a nap. We have a shortage of skilled worker, and we're going to have a shortage of workers as such. And social for us also means, as a home buyer, I have no choice. I get whatever the developer builds to me. I don't have choice to customize my home. I don't have choice to look for different designs. I just have to buy whatever I get from the big developers. On the other hand side, with environment, what do I have to say? It's all about making a big impact in the industry. I mean, we all know that the construction industry is one of the biggest industries in terms of waste, one of the biggest as well in CO2 emissions. So that are our two biggest targets as well. That's why we also align with the UN SDGs, 5 of the UN SDGs. And actually, how do we want to have a positive and environmental impact? Through 3 things. One is efficiency, second is sustainability, and third is digitalization of the whole build process. When I say efficiency, we will focus, obviously, efficiency through modern method of construction, more specifically category 2 panelized system. When I say sustainability, which is, as of today, the most environmental and renewable material, it's timber, and more specifically cross-laminated timber, and digitalization through our DBUS platform. But let me explain you what a platform is. Platform connects different members of communities and enables them to transact. We all know the Airbnbs, we all know the Ubers, we all know the Facebooks. But this doesn't exist for the construction industry. So who is our community? On the one hand, we have developers, everybody who builds houses. It could be landowners, it could be local authorities, it could be housing association, it could be an SME developer or an SME house builder. And on the other hand side, you have the supply chain. So the whole supply chain. And here is exactly what we're trying to achieve, is to bring together everybody who builds homes with the supply chain. And all in an automated process through an online home configurator for the home buyer. So the home buyer is empowered to choose his design, configure his home, and the whole process is then assembled on site by the developer. What is the impact? The impact is going to be massive, specifically for SME home builders. Financial, the cash cycle improvements, instead of build to sell, you're going to sell to build. And access to economy of scale of the supply chain if you are on a platform. Sustainability, we talked about the SDG goals of zero as well, and the aim here is to build zero carbon, zero waste homes. We're going to give developers, home builders, a 20% cost savings. Our own investment will be 3.5 million in technology, and we expect to have a valuation in 2025 of 175 million. The platform will be available in 2021, and what is very important for us, we deliver as well the goals of the industry challenge. Thank you very much.
Thank you very much. I've got about 15 questions, but I think I'll just stick with one. Thank you. I'll be here for I think we're going to be kicked out soon, to be honest. So I'll just go with one. So I'm going into your system. I'm configuring my home. How are you coping with the fact that different users have got different priorities? So one user may be looking for the lowest capital costs, some may be looking for the lowest running costs, or the lowest embodied carbon, or the most resource efficient, or the healthiest. How are you actually going to be able to give the user what they want according to their defined priorities?
So you're asking from the home buyer's perspective?
Yeah, I'm using the configurator,
Yes.
but I want the home that,
Yes.
is,
Yes.
presumably you're trying to tackle their wants and
Yes.
needs.
Yes. In this example, we have taken the Cambridgeshire Country Council as the local authority, which is going to offer, let's say, 50 new homes in their county council. So obviously the local authority will have to do the groundworks, will have to do the infrastructure, or through themselves or through a builder, but they will not have to build. The home buyer will use the online configurator and choose from different digital twins the house they want. It might be a 2-bedroom, a 3-bedroom, a 4-bedroom, and the different digital twin version will have different options, so you can configure your home. You might want the kitchen to be south-facing, you might want to have a bigger master bedroom, you might to have an open kitchen, whatever you want. And here comes the really, really empowering thing from the home buyer. You will be on the configurator, see the energy use of your home. And depending exactly how you design it, because you will be able to change window sizes, you will be most probably able to change orientation of the house, you will be able to affect the energy efficiency of your home. And also the configurator will have an environmental impact assessment automatically in the online configurator. So as a home buyer, you will know exactly what is my CO2 storage of the home I'm building. You will know exactly what is going to be my energy consumption and my energy bills. And you will even know the source of the supply chain, because the supply chain is predefined. So I will actually be able to choose my home specifically under these criteria.
I'm going to jump in here, and it's to protect you from the architect who sat next to me. So, have you been working with a number of architects, and what is their feedback that you've had in terms of your platform and the architectural freedom that Peter is going to quiz you on in about 30 seconds?
29 seconds.
27.
Part of our team, we have one of the strongest UK architects in terms of CLT and DFM. It's part of our team.
Okay,
and maybe spinning on further.
Yeah.
If you allow, imagine in 5 years' time, for instance, this platform runs. We'll have a community of developers, home builders, and supply chain integrated. The technology is there already. What would it stop another architect to submit his own designs to the platform? There's nothing which could stop him.
agree. And do you have a supply chain that can deliver at scale?
Yes.
And also, is it a volumetric or a panelized system?
Panelized system.
It's a panelized.
Yes.
I'm sorry, I've held Peter off as long as I could.
Yeah.
So I'm not going to ask that question there. But what I am going to ask is, how does this system change the behaviours on site? You started with a really good picture of traditional behaviour. I think to what we're all after is quality of delivery, quality of workmanship, which will deliver the performance that we're talking about. But I don't see anything in the system at the moment which is going to change those behaviours.
I mean, fundamentally, we are not building traditionally. We are building through modern method of construction, panelized system, where you will achieve in terms of quality. You will assemble on site. You will not build anymore.
I still think you're using the same behaviours, the same culture, the same people until you take the decision making completely away from site, and that has to be built into the system, doesn't it? And I think that's a challenge.
Which decision making do you mean?
Well, you've still got the same guys on site, whether they're putting up panels or sets. Well, we can take this. We're
I
being
think
told
we
to
can
stop.
continue this. I'm going to
Later
protect
on,
you from
yeah.
the architects by stopping the session, because we've got to go off and make a decision. But if everybody that's just pitched can come and sit up here, maybe we move on the slide to something more general. And then we're going to go off, but Seema's going to basically, anybody can ask questions now of anybody.
I'd like to ask Greg, how much energy does it take to make one of your plastic bricks?
Don't know, to be honest. A lot less than a brick, though, which, when you consider with a brick, it takes more heat to make the brick in the first place. It takes more petrol, etc., to get it to site, because on the back of a 27-tonner, we can fit 7 houses, whereas on the back of a standard lorry, you can only fit roughly sort of 0.9 of a house, depending on the size of the house, of course. Does that answer your question?
Is there any more questions on the floor? Do you have any questions to each other?
Hello. The one about the dual source heat pump. Yeah, you. Sorry. Have you looked at fitting this onto house, or is it more of a commercial use? Do you see this being fitted onto houses, or is it just more of a commercial use? Sorry. Do you see this being fitted onto houses, or is it only commercial?
Actually, it could be available to residential and public building, as long as your roof space was solar panel, and the heat pump could be storage room. It's not very large. Okay, come back.
How much surface area would you need for?
Depend heat demand of the house. So if you make use heat pump, you can reduce the area of solar panel. It's totally flexible. You can make double choice and either heat pump and solar panel, or you can have both combined together.
I've got the question for the last presenter about the house configurator. How far are you with your technology? Have you started development yet, or is that the conceptual stage?
No, we started to develop.
Cool. I'll come and talk to you later.
Pleasure. I guess what you haven't all seen is what the challenge was, and it covered quite a breadth to be satisfied. So I've been a bit greedy in trying to satisfy all the criteria that's been laid down. I guess I've come from a more human side of the background. You know, we've got a shifting demographic. There's problems with labour. I think I've shared with you some ideas of solving the skills crisis in this country, reducing 8 miles per gallon trucks on our roads, getting rid of the congestion. You know, 1 million people between Oxford and Cambridge, that's a lot of people. I think we're being a bit naive in some of the competitions going on at the moment. They talk about the Garden Village movement and all the rest of it. There will be no Hampshire and Oxford left. So the challenge was to satisfy about 6 or 7 different criteria. It's actually really hard to do. And I have come across as a maximalist, I guess, slightly insane perhaps, I don't know. But to satisfy the holistic approach to the challenge set is quite a feat. I think I'm not as advanced as a lot of you guys in lots of ways, but to somehow weave through the challenge set, it has been quite hard. And there's holes in mine, and I guess holes in yours as well. But you know, if we're to change things, then we need some bravery. My business plan, quite rightly, I need focus, but I need support. I think we all need support. Innovation grants, you know, the success rate's very low. It's something like 8%. So if small companies are spending a lot of time on these sort of ideas, and only 8% are getting through, that's pretty bad. So if we're going to save this planet, then we need lots of support. It's not really a question. I guess it's an observation.
Can I have one question about the thermal imaging? That you mentioned that the end goal maybe is to incorporate it into EPCs and to the RV sub, which is something that would be fantastic for the whole industry, and products like ours could also use that. And we actually used thermal imaging before, and it does flag up issues where the heat is escaping. What do you think, how far it might be, how close it might be? Because a lot of us would like to see that.
I think to start with, just having the EPC form filler out, look at the video, would actually help him make some of the right decisions. But through that, you've got various stages which go through to actually other concept of using the thermal camera to actually throw U values into the EPC, into the SAP calculations. Because all the U values are from a database, and I recently learned that our U values are all done on totally dry installations and walls, and so we've all been using the wrong figures for about 60 years. We need to be measuring them in the real world, like the University of Bath have started doing under a BRE contract. So it's a slow start at the beginning, but I'm working with an SAP assessor on this. I've got a question for you while we've got the microphones on. Sure. With your magic vent controller rig, where it is used for the void underneath a suspended floor, Am I right? You're actually relying on there being some coupling between the air in that void and the air in the room. When in fact, in trying to make the house reasonably airtight, you're going to be sealing up all of that anyway. So it would take away the need for controllable vent in a suspended floor, which has had refurbishment done to it.
So sealing up doesn't really happen as quick as it should be, but also we did look into not only the U value improvement, but also the air tightness improvement. So we've done loads of air pressure tests like before and after, and there was a really good like 10% improvement on the overall dwelling air tightness. So it does contribute to sealing the properties, and the UK housing stock is far away from being airtight just yet. So there is.
I agree we'll do that, because what you will be doing is you'll be closing it off for a percentage of the time. So you won't have that source of air going underneath the floor. My point is that as part of the refurbishment of the house, you would naturally look at trying to seal up the floor between floorboards and skirting boards and so on. In which case you then won't have that coupling between the underfloor air and the building. You might as well just work with an ordinary air blick and let the air flow through it.
So we've done experiments with both non-sealed off, so where gaps between the floorboards, but also with already sealed off ones, and the impact was still quite reasonable. So it works in both.
I can only assume that's then because you haven't got a constantly replenishing cold air running through underneath. You've closed that off, so the air that is trapped underneath the floor is able to warm up a little bit and not pull so much out of the floor above it. That brings in the question of what happens when you insulate the floor.
Right, if you can insulate it. So I would suggest maybe to leave for others as well to contribute, but if you can insulate, because in a lot of cases you just absolutely can't, otherwise like taking up everything.
Actually, I've got a question for the audience. How many people own a car? Most of you, okay? So I guess what I was going on about transport, I think it's used perhaps 6 hours a week and sat doing nothing for 160 hours a week. So I think that might need to change, I guess, if we're going to have more and more people in cities. And how many people here would like to build their own house? And perhaps you might want to chip in on this one. Would you like to build your own dream house? And how many people find the selection of houses incredibly dull? Me too. Yeah, absolutely tedious. So, you know, perhaps the future might be with some robotic assistance, with this platform, you know, perhaps with a container that arrives with all the right tools in, that you could self-build your own house, with some remote robotic worker helping you. And perhaps you drop the car off at work and it goes and earns you a crust because it's autonomous. And when you want to go home, you press a button on the phone and it picks you up. So while you're asleep, it's also delivering goods, so we can get rid of the Amazon white van man delivering little bits of packaging. You know, I think this is the sort of future, I think, and choice of architecture. Get rid of bland architecture. You know, in the MOD and Cherwell Council up at Bicester, I've got 2,000 plots where you can build what you want on there. They've got a very loose passport. So you can build your dreams. You can make houses a lot more exciting. So I think the future is really exciting.
Right, we've made a decision. It took us ages, actually. It was a very difficult decision to make, but we do have a winner, and I'm going to announce the winner, and then my colleagues here are going to give a bit more information about why they won. So, yeah, we'll get a group picture after. So the winner of this lovely trophy is Cheese. So, well done. We'll get pictures afterwards. But we're going to add in a bit more information now about why Cheese won.
So a few words as to the deliberation we just went through. It was very close, actually. I think what we liked about the thermal imaging process, I suspect the announcement of FLIR with their add-on system was a bit of a pivot point for you as a business. So overcoming adversity is certainly something that I would admire, and I like the fact that you've been through that. What's really interesting is the fact that you've got this community engagement activity. So we have a number of stakeholders coming together, trying to solve this problem, not necessarily just making it a one solution fits all, but trying to democratize that process. And I'm very, very happy that you've taken those leaps forward to try and do that. I will say there are some challenges in getting you to scale. It is something that, in my role, I currently look at that problem. I would like to see you use more advanced analytic technology, look at how you can scale that proposition as to community solving their own heat loss problems and diagnostics and improvement. So what I will suggest is if we could have a dialogue and we can maybe help you on your journey as the Active Building Centre, that's something that I'm more than willing to try and do. And we'll certainly have a discussion offline. Is there anything else that you wanted to add, Peter?
I'd say very well done to everybody. I do think, though, anybody entering any competition like this should have one thing in mind, and that is, can I make my proposition absolutely clear to the judge? Because that then gets you over a big hurdle, and it means that we can move on quickly in terms of having a look at the characteristics. Sometimes everybody's enthusiasm gets in the way of the message, and I'll leave you with that thought. Thank you very much.
Thank you very much. So congratulations to everybody for getting through to the shortlist, and congratulations to the winner in particular. And thank you everybody for staying here and enjoying the discussion and also asking all the questions. So thanks everybody.